recording is not.
Yes, it starts.
Yes, Doctor, it's recording.
It is recording, yeah? Okay. You are recording, okay. So for linear regression, we already discussed it, where you can approximate the data by a straight line y equal to a plus bx, and you can, based on the historical data, you can get these coefficients a and b. B represents the slope of the line and A represents the intercept of y-axis, and you can easily implement such formula to get the straight line equation. And this is was an example. You have here the average of x, the average of y, and then you can get xy and x square, and you can sum them up, and you can get b, and then you can get a, and then you can have the straight line equation, and you can, at any period, you can just substitute by x equal to the period number 13, for example, and then you can get the forecast. Okay, so this is the linear regression. Now, if we have a seasonal pattern in the data, like the year can be divided to 4 quarters, and the load pattern is changing from one quarter to another. So in this case, you can consider the seasonal impact on this. And here we defined the seasonal factor SI, which is represents the demand of that season over the total demand of the year. Demand of the quarter one over the demand of the year, demand of the quarter two over the, this gives you another seasonal factor and so on. So the steps here is very simple. You can calculate the average demand per season, calculate the season factor for each season, calculate the forecast as usual using whatever method you can implement, moving average or linear regression, and then you can adjust the forecast by multiplying the forecast by the seasonal factor. And I think we covered this example, right?
No, Doctor.
No, we didn't.
We stopped at this example.
Okay. So we have here the demand per quarter is given as shown. Find the seasonal factor of each quarter, S1, S2, S3, and S4, and then forecast for year 2005. You are given here demand for 2002, 3, and 4. Then we need to forecast for 2005 and use the seasonal adjustment to forecast for each quarter. We will get the total forecast for year number 2005, and then we will divide this total forecast to season forecast using the seasonal factor calculated here. So we just implemented the steps discussed in the last slide, and we will follow here. You have here year number 2000, 2000, and so you have here Q1. These are the demand. You can get the total demand of for the 3 quarters, and the total demand for Q2 these years, total demand for Q3, total demand for Q4, and total demand for all years. So what you can do is to divide 42 over 148. So this gives you S1. If you divide 42 over the total, you can get S1. 29 over the total, you can get S2. this over the total, you can get S3. And then this over the total, you can get S4. So you can calculate the seasonal factor, S1 equal to demand 42 over total here, which was 148.7. So this is the contribution of that quarter over the total demand, 0.28. We will use it later on when we find the total demand of year number 2005 based on the demands of 2002, 2004, 3, and 2005. We will get the forecast, and then we will divide the forecast based on these seasonal factors. For season number 2, S2 equal to D2 summation of D. So this is 0.2. S3 equal to 21.9 over this, so 15%. This is a contribution of season number 3. And season number 4, you have 37% of the contribution to the total demand. Now, this is the seasonal factors. How to get the demand forecast for 2005? Can we get the forecast for 2005 based on 2002, 2003, and 2004? So you are given here 3 historical data for period 1, period 2, period 3, and these are the demand. So can we expect what is the demand forecast for 2005 and the 4th period? Okay. So can we implement any other method, to get the forecast in the 4th period or 2005?
Can we use moving average?
Yes, you can use moving average. Let us, in principle, you can use any forecasting technique as we mentioned. Abbas Saeed, do you have a question or do you have an answer?
Answer.
Okay, so what is your answer?
I think we can take from the total of 2002, 2003, and 2004. We find by one of the method the total for 2005, and then we multiply it by the season factor for each season.
Exactly. This is what we will do. We calculate the seasonal factor here. So the next task is to find the forecast based on this historical data. 45, 45, 50.1, 53.6. We can say, let us take that method, which is a linear regression. You have period 1, and this is a demand. Period 2, this is a demand. You have here X, and you have here Y, 1, 2, 3. So this is 45, this is 50.1, and this is 53.6. So can we get the average? Can we get the average here? Can we get XY? X multiplied by Y. Can we get X square? Can we continue here for these 2 columns and substitute in B and A to get the straight line equation, and then we can get the forecast in the 4th period. This is 1, 2, 3, and 4th period will be 2005. So we can have X equal to 4 and substitute if we have the straight line equation. So this is what we will do exactly. So you have any period here, number of period is 3. So these are the demand for the last 3 years. And this is the XY, 2 times 50, 3 times 53. And this is X squared, 149. And then you can get the total. And you have here the average. We need the average of X. So this is 2. The average of Y, we divide by 3, number of periods. So Y equal to, average equal to 49. We substitute to get B, and we substitute to get A, as usual. And then we can find out the linear trend line, which is Y equal to 41 plus 4.29 times X. And for forecast 2005, this will be period number 4. So F4, we substitute X equal to 4. So we get 58.16. This 58.16 gives you the total forecast for the 2005. So the next step is to divide this total to the seasonal patterns. Ahmad Fahd, do you have a question?
Doctor, why we didn't find the average until period 4? Then substitute by 5.
لا هو what we are given is the data for 2002, 2003 and 2004. So
okay.
we have only 3 periods given.
Okay.
And we need to forecast for the 4th one.
Okay.
So this is not this total, or this total is not the a year. يعني it is not taken into consideration when you have the historic. This is not historical data. This is the historical data. So you are given 3 periods and you forecast for the 4th one. So this is very simple. You can get the forecast for the 2005, which is 58.16. So what is the next step? Is to multiply this 58.16 times S1 to get the forecast for the first season, times S2 to get the forecast for the 2nd season. Total forecast multiplied by S3 to get the forecast for the 3rd quarter. And S4 multiplied by the total forecast to get the forecast for the quarter number 4. So طبعا the summation of those will equal to 58.2. But you distribute the total demand over the seasons using this seasonal factors calculated earlier. So this is the how to consider the seasonal impact on the demand forecast. So by this the example is done. So do you have any question? Otherwise we move to the accuracy of the how to evaluate the accuracy of the forecast. Any question? Okay, let us move to forecast accuracy. How to evaluate? Okay, we evaluate the forecast here, as you see, but how can we evaluate whether this is a good forecast, or we need to adjust, or we need to change the method? We need to play with the designing factors, like in moving average. What are the window or number of periods that can be considered? Also for the smoothing factor, or for the exponential smoothing, how much alpha you will set. You can play with it in order to improve, but you have to have a guidance that gives you whether your forecast is good or bad. So these are the forecast accuracy measures. We will consider here 3 accuracy measures that should be calculated in order to assess your forecast. The forecasts are rarely perfect, as you know. Need to know how much we should rely on our chosen forecasting method. Measuring forecast error, and this is the forecast error, dt minus ft. You have the demand minus the forecast. You have historical data, and you apply one method to get the forecast, and then you have the demand and the forecast, and then you can get the forecast error, et equal to dt minus ft. Note that you may have over forecast, so the forecast is higher than the demand, so you have negative error, or under forecast or underestimate, so this is a lower value than the demand, so the error is positive. Whatever error is positive or negative, we will consider in our measures, we will consider either the scalar value of E or E square in order to get rid of this minus sign or positive sign. It was estimated that an increase of operating cost associated with a 1% increase in forecast error was 10 million sterling pound per year in UK. This is to appreciate the importance of having accurate forecast. We have three measures here for the forecast accuracy. It is the difference between a forecast and the actual demand. This is the error. So we have what we call the mean absolute deviation. Mean absolute deviation. This is one measure. We will define it mathematically in next slide. We have another measure, which is mean squared error. Mean squared error. Another measure, which is the mean absolute percent deviation. It is similar to that one, but you get it as a percentage of the total demand here. And this one is almost similar to this one, but you have here as a percentage of the total demand. Okay, let us see what is MAD, mean absolute deviation, how to calculate it. You are given the demand and you apply a certain method and you get the forecast. So you can calculate the error, dt minus ft, and you take the summation over the absolute value of the error. Whether it is positive or whether it is negative, it is an error. So you take here the absolute value of the error, summation over the number of periods. So you can get the mean divided by number of periods. So it is a mean, average, mean absolute, error is absolute, deviation, طبعا this is an error. So this is the mean absolute deviation. This is very simple to calculate. If you have the demand and the forecast, you can easily get the summation of the absolute value of the deviation. So this is the mean absolute deviation. Okay, so mean square error, this is the mathematical representation of the mean square error. Mean, and we divide over n square, and we have error square. We have the error square, dt minus ft. So this is the error square. And you have the summation of all the errors, and then you get the mean value. So this is another number which you can, based on this value, you can judge whether this method is better or the other method is better. So ET, the forecast error, in a number of periods, and of course DT and FT are defined earlier. The third measure, which is accuracy as a percentage of the total demand. It is an error, but divided by the total demand. So you have the error here, dt minus ft, and you get the absolute value, and you divide over the total demand to get the percent as a percentage, or a decimal number, whatever. You can of course multiply by 100 to get as a percentage. Anyway, this is the third method that can be easily calculated if you have dt and the forecasted value ft. So let us implement these methods on the last example, and considering different methods: moving average with 3 periods, moving average with 4 periods, 5 periods, smoothing factor was alpha equal to 3 or alpha equal to 5, and adjusted the exponential smoothing with beta considered as whatever. Linear regression also can be considered. All these methods, we can evaluate them against these accuracy measures. Muhammad Hassan?
Doctor, how can we choose between these methods?
انت you have different methods as we mentioned: moving average, exponential smoothing, adjusted exponential smoothing, and then we have this linear regression and so on, right? You have
Yes.
4 or 5 methods. حتى each method you can have a variant of each methods. Like moving average with 3 period, moving average with 5 period, smoothing factor alpha equal to 0.3, smoothing exponential smoothing with alpha equal to 0.5, adjusted with alpha and beta equal to certain values, and so on. So each method you can have variants of that method. So how to evaluate, how to judge which method is the most accurate? You can, based on these 3 measures that we defined, mean absolute deviation, mean square error, and the mean absolute percentage deviation, you can calculate for each method these 3 accuracy measures, and then you can judge based on these accuracy measures. You can judge among the forecasting methods. Is it clear?
So I have to test all these 3 error forecast.
Yes,
Forecast error.
against each method you consider.
Okay.
Okay. Let us take the example. Example will clarify all these points. Okay, so this is an example. For the data shown, calculate the forecast using the following methods. First method, exponential smoothing with alpha equal to 0.3. Second, alpha equal to 0.5, exponential smoothing also. And then calculate the forecast using adjusted exponential smoothing with alpha equal to this and beta equal to 0.3. Using the linear trend line. These are 4 methods here you need to compare. Okay, so you will implement all these methods on this data in order to get the forecast. Once you get the forecast for each method, compare the accuracy of these methods using the 3 accuracy measures that we define: mean absolute deviation, mean square error, mean absolute percentage deviation. Okay. طبعا احنا we will not here for this example, we will not repeat whatever we already considered before, and we solve this example. Are you still remember? Do you still remember this? Now we solve this example when we talking about the exponential smoothing.
Yes, doctor.
And 0.5 also, and we compare among these. And adjusted exponential smoothing, we solve this example when we consider alpha equal to 0.5 and beta equal to 0.3 earlier. A linear trend line, we already get the linear trend line of this, which is y equal to whatever, you just have it before. Yeah. Okay, and we solve this also example. So let us see the forecast for each method. Exponential smoothing with alpha equal to 0.3. So this is dt, and this is the data given, and this is the forecast. And with this forecast, you can calculate the error. The error equal to 40 minus 37, 41 minus this, 37 minus this. So as you can see here, the error could be positive, could be negative. But with these measures, it doesn't matter. It is an error, whatever. It is a deviation from the actual value. So the accuracy measures MAD, mean absolute deviation, which is defined as summation of the error over n. So a number of periods here, you can exclude this one, this period, and there is no forecast here. So you can exclude this period, and you have here 11 period, So you can calculate summation of all this, not algebraic summation, but you have the summation of all the absolute values. So this minuses will be also converted as positive. So you add all this up, and this gives you equal to 53.41, and you have a number of periods 11. So you can get MAD equal to 4.86. So this is the first accuracy measure against the exponential smoothing. For the mean square error, again, mean square error equals summation of error square over n. So this, the error, so you square the summation, square and sum and so on. So at the end, you have the summation of all these squared equal to 376, and you divide by 11, so it gives you MSE mean square error equal to 34.19. The third measure, the mean, this is written, you have here B missing. This is the mean absolute percentage. We have B here. So summation of the error is already calculated here, 53.41, and we divide over the total demand. The total demand, if you add all these demand up, so it will give you about 520. So if you divide this over 520, you get it as a 10%. Okay, this as a 10%. So this is MABT. This is MAPD, and this is written wrong. Please correct it in your handout. Muhammad Hassan?
Yes, Doctor, here, can we consider this a good forecasting or not?
Here, we cannot judge. لأنك أنت in order to judge whether this is good or bad, you have to compare between different methods, not between different accuracy measures. Okay? يعني let us take another method and we compare MAD here with MAD of that method, MSE with MSE there, MAD with BD there. Okay, in this case, we can judge which method is good or better than the other. Okay, is it clear? يعني
Okay.
here we cannot judge. It seems in the values here is high. You have here 4%, which is high, 34, 10%, which is يعني, but let us see the other method and we compare. Okay.
But why we use all these three here?
Hmm?
Why we use all these three forecast error?
This actually like يعني you can of course consider only one if you want, but definitely if you take for example 380 مثلا, 380 you have some kind of performance indices. Could be the average of the error, could be the mean square error square, or you have the absolute value of the error. So there are يعني some pros and cons for each one. يعني for example, and I don't want to elaborate here more, but for example, let us approximate it to what we have for if you have a function, I don't know. Oh, let me go to the presentation mode in order to have this bin writing here. So, for example, if you have y equal to x square, okay, y equal to x square. So this is the function y equal to x square. So this is the parabola like this. طيب y equal to x, the scalar value of the x. So this gives you scalar value of the x, right? If you search for the minimum value, what is the minimum value here? Or what is the minimum value of what is the value of x that gives you minimum value of y? You can say
zero.
X equal to 0, right? Yeah, I will come back to you. X equal to 0 here. But when you have this derivative methods in order to get, you have the tangent here and tangent here and tangent here, and you have convergence until you reach to this one. So you may stuck here at 0.01 or 0.0 or minus 0.01, and the curve here is flat. But if you look at this, the curve here is not flat at this value, right? So you have certainly value equal to 0 here. And you have some fine differences among these accuracy measures. You can only consider one and you can judge based on it. But we give you different measures in order to practice any one of them. Abdullah Abdul Karim, your question?
Hello.
Yes.
Yes, Doctor, I do have two questions.
Okay.
The first one, for the second method, why don't we take the square root for the 34?
Okay. If you take a square root, خلاص, you define the measure as a square root, and this will be implemented for other methods as well. يعني هي الفكرة في ايه يا شباب هنا؟ الفكرة انه هي measures. Okay. If you implement them all in all methods that you consider, that's fine. And at the end you will judge which one is better. يعني if you take the square root of here, okay, let us in the other method also we take a square root of mean square error. So it doesn't matter. لأنه if this is 34, the root square will be let us say 5.5. If the other methods comes to مثلا 70, so the square root of 70, this will be 8 point something. So based on this, you can judge, and this one is better. If this is 34 and this is 70, again you can also conclude that this one is better. Is it clear?
Maybe if we took the square root, we can measure the MAD with the MSE, because they will both be representing the difference between this number and 0. Like how much does this, for example, the MAD is 4.8, which means it's most of the points are 4.8 far of the right point.
Okay.
Or the accurate point. And for the 34, it doesn't make sense because we took the square root, we squared it. So we have to take the square root back so we can see a real difference. Do you see what I mean?
You will take the square root of what?
Of 34. Because we squared the change, which is one of the known ways of finding the error. But we have to square it to take the square root again, so we can make sense of the number. 34 does not make sense.
Yes, يعني as I mentioned, yes, it doesn't make sense. What is the 34? لأنه you have here the error square divided by n. When you will take, it doesn't make sense. But when you compare different methods together, so you can, based on this value, you can judge which method is the best. This is what we want to say. Is it
Okay,
clear?
that's question 1. Thank you. For question 2, I suggest, or I have a suggestion, that we can take 30% of the data out before we do the accuracy measure, and then we compare between the real data and the expected data. For example, if we didn't consider period 10, period 11, period 12, and then we implemented different ways of forecasting period 10, period 11, period 12, and compare those numbers from the real ones. And that will give a very accurate way.
But why do you exclude this period?
Because I want to compare them at the end.
Okay, and you need to divide the data set to 2 parts.
Yeah, 70%, 30%.
Okay.
And 70%, I will use them to predict the 30%. And then I will have the 30%, the real ones, ready to be compared to the forecasted ones. And then I'll compare which forecasting method that worked well, and I'll use them again for the, let's say, period 13, period 14, what I need.
Okay, such approach, Abdul Karim, such approach used in training and testing phases of what we call the neural network. You divide the data that you have to training data and the testing data. And you can calculate the error in training and also the error in testing. You are right, you can do this. It's not there is no problem with that. But if you are given such data, you can consider this as now we are in the training phase. Okay, we are in the training phase. We need to find out which method is best based on this for the training. For testing, yes, later we can do. If you still remember the flow chart that we have for forecasting issue, do you still remember this flow chart?
Yes.
This flow chart, you have 2 loops that can be, yes, here it is. Up to this one, you have here starting 1, 2, 3, 4, 5, 6, 7, and then 8B, and then you go circulate here. Okay, so this is for training phase. This is for the training phase. This is for the data that you have. And this, when you go to this one, and you are again, you find the forecast, and then you check the forecast error again, and then you may need to jump from this loop again back to this loop. Okay, so this loop represents training, and this loop represents testing. Right? Are you with me?
Yes. Yes.
So in this case, now what we are having in that example, we have the training phase. We need to find out which method that represented the given data accurately. Okay?
Yeah.
Maybe later, when we have some, or we keep some or part of the data for testing, then we can test the methods and we may go and refine it again here. Okay? So you are right, we can do this, but let us consider here the training phase only, that we have such data, and we need to find out which method of these methods is the best one to simulate the data. So these are the error, okay, and calculated. This is for exponential smoothing only. We go for the other methods with alpha equal to 0.5 again. Yeah, عفوا معنا علي السعيد برضو مكي. Do you have a question يا علي?
Yes, doctor. Why here they choose n to be 11? I think it's supposed to be 12 because we have 12 period.
But it is not يعني it is not right يعني to use 12 لأنه how much this forecast would be? Are you going
zero.
لا زيرو لا يعني زيرو لا ما ينفعش تقول زيرو.
ليش؟
يعني اقول لك الفوركاست يعني انا عندي 37 الفوركاست ده هيبقى زيرو معقوله؟ اتليست تقول 37 اتليست
اوكي
اتليست خلاص consider 37 okay consider it as 37 and divide by 12 okay no problem no problem you can consider this 37 okay which gives you an error equal to الايرور لما تبقى تجيب 37
0
يبقى it will not يعني add much on the summation here and you divide by 12 it doesn't matter yeah, it doesn't matter. اللي انا عايز اقوله انه this value whatever the definition here is if you implement the same definition to other methods then you can compare with this value either 4.8 or 2.3 or 4 and so on, right?
Yes, doctor. Thank you.
So okay, so the second one, which is the exponential smoothing, you have this is the based on alpha equal to 0.5. This is already solved earlier, and then you can calculate the error, and you have here some error is negative here. Whatever error, positive or negative, we consider the scalar value or square value. So this value is here equal to 4.04. What about the other one, the previous one, where alpha equal to 0.3? This value was 3.4 maybe, or 4.3? 4.8. 4.8. Now here this measure for this method alpha equal to 0.5 gives you 4.04. So here you can say in this method with alpha equal to 0.5 gives better results compared to alpha equal to 0.3, right? Is it clear?
Yes.
يعني what I want to say in 4.04 doesn't make any sense unless we compare it to other value, the corresponding value. Here, yes, we can say no, this is better than the previous one. For mean square error, again, this is the error. If you have the square value and you divide again, so it is 24. If you compare it with 34 in the previous method, then you can judge in this, based on this measure, this method is still better than the previous one. For the other method also, MAPDB is missing here. You can have it 8.5. Before it was 10 point something. So alpha equal to 0.5 gives you better results than alpha equal to 0.3. Let us see the third method, which is the adjusted exponential smoothing, alpha equal to 0.5 and beta equal to 0.3. So we already solved this example and we get the adjusted forecast equal to this, and you subtract, you can get the error in each one, each case, each period, and you can implement those measures. For the first one, summation of all scalar values of these errors over the number of period equal to 11, it gives you 3.8. So we have better results than the previous two methods. Okay. and the mean square error squared over n, it gives you 21. So it is also better than the other methods in terms of MSE. And this one, again, this is the missing here. So you have 8.06. This is the third method, and these are the accuracy measures associated with that method. For linear trend line, we already solved it before. So it comes to y equal to 35.2 plus 1.72. So based on this, we can get the forecast. And this is the forecast, and this is the error. And then you can apply the first measure, 2.49. Oh, this one is much better than the three methods discussed earlier. So that means, you know, linear trend line is better than the others. And you have here a mean square error again. You squared all these errors and divide by, and this will equal to 9.46. And 9.46, you compare it with the 34. 9 doesn't make any sense. Yani, what is the 9? 9, physical meaning of 9, it is just a reflection of how much error do we have. So if you compare it with the method that gives you 34, this one is much better, of course. So, and this also measure or divide by the total demand here. So it gives you 5.27. So we can highlight all these methods that we discussed. These are the four methods that we are considering here. And these are the measures that we calculated. You can use only one measure, for example, MAD. Can you, based on MAD, can you judge which method is the best? هادي.
linear trend.
طيب هادي علي, you have a question?
الحين اذا بسوي فوركاست او ابغى اشوف اللي هو اكيوريت، يعني لازم اخذ اكثر من طريقه عشان اشوف اي طريقه هي الاكيوريت يعني دكتور ولا؟
مش لازم تاخذ اكتر من طريقه. مش لازم تاخذ اكتر من طريقه، وده هنشوفه دلوقتي. يعني if you look at the trend here, if you look at the trend here 4.8 4 3 طبعا ما بنبصش احنا كده. احنا we are not looking horizontally. Okay? We are not comparing between the accuracy measures. We comparing among the methods. We look vertically. This is 4.8. This is gives you 4.0, 3.8, 2.4. The trend is clear, and this method is better, with the best. Okay. Right. Forget about this measure and consider only that measure. This gives you 34, 24, 21, 9.4. Again, based on this method is the best. For the other method, other accuracy measure, you have this 10, 8.5, 8, 5.27. Again, this one gives you the best result. Is it clear?
Doctor, but can we compare which measure is better?
لا, we cannot compare among the measures.
Okay.
يعني we cannot compare among the measures. انه هتقول انما الترند واضح. يعني احنا بنقارن according to accuracy measure. Let us take this measure and compare among the methods considered here. You can take this measure only and compare among the methods considered here. Or you take this method accuracy measure and compare among the methods. We compare vertically. Okay? Is it clear?
Yes, clear.
So in this case, you can easily figure out in the linear trend line for that data given gives you the best accuracy according to MAD, according to MSE, according to also MABD. So which method would you prefer? Definitely this one is the best method for خلي بالكم أنا this is very important point إنه based on the data given this is the best but it doesn't necessarily true إنه this method is the best for whatever data that you have. Probably, okay, if you have here this 1 point, this 1 point, this 1 point, and this 1 point, this 1 point, and so on, these are the data. If you consider only the 3 first mid period and you approximate or you forecast according to the linear trend line. So the line would be like this one. Okay, so this is the line, forecast line. And of course, the forecast line gives you huge error here, huge error here, huge error here. So it's not necessarily true to have a line trend line. Our linear regression method is the best for whatever data that you are given. So you have to be careful. This is why we need to examine different techniques and check the accuracy measure in order to figure out which one is the best according to the data given. Any question? Any question?
Doctor, I think we have to use Excel or any program if we have a lot of data here.
Definitely, as I mentioned, no, here for the forecasting, you can use Excel sheets, okay, for calculation, and also you can program if you have like a programming MATLAB programming, you can just very simple code with 4 loops, some 4 loops كده in order to calculate the average, the XY, some X square and so on, and then you can get summation, and you can easily have a very simple program to do it.
I think the code is available on the book, the software copy. You can just copy and paste in the MATLAB.
Which book? Which book?
The book, the course book. Because when I took EE463, it was attached, the code with the...
هذه سعادات بوك ولا؟
ايوه هذه سادات.
في forecasting method؟
ايوه حتى في بجوجل في نفس الماتلاب، يعني ناس يسوون كود يرفعون على
exactly. طبعا هتلاقي موجود في يعني هتلاقي موجود كتير في الانترنت. You can just download and do it. طيب I will give you very quick quiz.
دكتور في داتا كثير ولا كيف الكويز؟ لأن أحس إنه يبي لها برنامج.
شوف الكويز وبعد كده ايه نقول. اوكي. I doubt انه محتاج كتير calculation. So we will it's supposed to have it now available to you on Blackboard.
The quiz for 10
on Blackboard. الكويز on Blackboard.
The time period for the quiz.
5 minutes.
دكتور
يس.
بدأ الكويز.
نعم.
تقول فيه بتعطينا كويز الحين ما حصلته.
البلاك بورد. Do you have البلاك بورد؟ Did you open the black؟
لا بقى.
Go to the blackboard. احنا قلنا ان بعد كده كل الكويزز based on your يعني recommendation to be in blackboard. بس انت كده متأخر يا اخي. انت كنت مستني ايه طيب الفترة اللي فاتت دي؟
دكتور ما في شيء.
كيف؟
دكتور
شباب.
دكتور نكتب التقريبي ولا كيف الجواب؟
والله اكتب اللي انت عايز تكتبه يا بس هو الناس هي بتحل يا اخي اللي بيقول ما فيش شيء.
دكتور ما حصلته في التست في
ميتو يا دكتور.
لا انت تاخرتوا بقى يبقى يبقى هو اتشال من عندكم لانه انت تاخرتوا في الفتح لانه هو ليميتد يعني ما احنا هنبدا مع بعض وننتهي مع بعض اذروايز انه هيبقى في مس ماتش كل واحد هيفتح في وقت ما هو عايز فده طبعا this would be يعني we will struggle here. انما طبعا انتوا يعني الساعه بقت 1:32 المفروض انا set it to due 1:31 display until 1:31 please and I will open it again or do it again for up to 1:35. احنا مش هنقعد في الكويز ده 5 minutes or 10 minutes. احنا قلنا 5 minutes only. انما كده it will be يعني be careful. Does it appear?
Yes دكتور.
طب يلا go ahead.
يقول دكتور ان I can't complete this.
You can?
It said this test cannot be completed because the due date has been passed.
افتحه تاني.
هذا هو كان ما يطلع لي شيء الحين طلع لي بس اذا جيت اقول begin يطلع لي هذا اللي مساقط لك.
due date
الديو ديت نفسه ما تغير يا دكتور.
يلا شوف كده يلا. لا كده احنا ده كل كويز لو بالصورة دي هتبقى
هذا هو طالع يا دكتور.
طب يلا take 2-3 minutes to finish. احنا we may start لان احنا كده خدنا وقت اكتر من اللازم بصراحة.
Doctor, can you extend the time? I mean, to close
The
it.
time was short, very short.
يا اخوانا يعني هنعمل ايه في التايم يعني نعمل اكتر من 5 دقايق. انت لما تفتح
Doctor, we didn't expect. I mean, to move to.
ايه؟
Blackboard. When I start, I didn't.
Once you open انت عندك 5 دقايق يعني once you open the quiz you have 5 minutes.
Yeah, but the quiz it takes more than. I mean, the calculation by hand it takes more than.
Yes, the calculation by hand is difficult.
طب انت خلاص المفروض ان هو تسلم الكويز anyway مش كده؟
اي والله دكتور تكلم ما لحقنا على الوقت.
يس
It's an easy but
الوقت قصير.
ايزي هو بس الوقت يا دكتور.
بنص الحل وقف.
الوقت بس هو الربط بالوقت.
طيب اوكي انا خلاص طبعا it's difficult now to start it again.
يا دكتور انا جبت المعادله بس ما مداني اعوض حتى اخلص الوقت قبل.
إيه بالضبط نفس الشيء.
انا جبت المعادله كلها يا دكتور.
طيب
ارسل لك المعادله دكتور.
يعني هو الوقت يا دكتور، يعني احنا فاهمين الفكره بس الوقت.
طيب خلاص خلاص
ارسل لك الحل يا دكتور.
لا ما انت خلاص مش مشكله بقى يعني. طيب انا اقول
دكتور
يس
دكتور الجريد دايركت يجي ولا؟
المفروض طبعا الجريد
ايوه يجي دايركت.
احنا انا وي كان مانج يعني وي كان مانج يعني لو التايم لو ده كومن لو ما فيش حد يعني قدر يوصل للفاينل التايم يعني ايشو عند this would be considered. ابراهيم عبد الله do you want to say something؟
يا دكتور يا ريت يكون في بوليسي واضح للكويز، لان الطريقه هذه ما احسن اخبط وبتضيع علينا درجات كثيره. يعني يكون مثلا يكون في دكتور مقسم في سكيجولد كويزز وفي باب كويزز، يعني عشان يكون في الصوره عارفين. لان زي ما تعرف ان الكورس عليه جريد، ما هو يعني باس ولا فيل كذا، والوقت قصير مره، فكذا بتضيع علينا درجات كثيره.
احنا يعني المفروض انه الكويزز here we have two types of quizzes. This is pop-up quiz. Okay يعني ده كويز اونلاين على طول مع we have also other quizzes at the end. خلصنا اللود فوركاست. Okay we will give you a quiz like 3-4 question 5 question on the load forecasting in general. Okay so this is the quiz for the load forecasting. انما
انا حليت لك
quiz. اوكي طيب خلاص يعني دي البوليسي. يا مين اللي معانا كان بيقول على البوليسي؟
ابراهيم يا دكتور.
You have other proposal then suggest please.
لا انا دكتور، انا من وجهه نظري يعني اشوف انه مثلا يكون فيها دكتور مثلا 15 درجه للكويزز تكون مقسمه، مثلا قسم للتست، قسم للكويزز، وقسم للباب اب كويزز، يعني بتكون عليها اقل شيء للباب اب، لان ما نكون محضرين يا دكتور للكويز. يعني مثلا لو تكون مثلا 7 للتست 5 للكويزز و3 للباب اب، اشوف انا من وجهه نظري انها ممتازه كذا.
طيب يعني الريشيو دي ممكن نبقى نتحكم فيها بعدين. يعني هو بوب اب كويز عليه درجه، يعني جبت درجه او ما جبتش مع البوب اب كويز بتاع اللاست كلاس اند سو اون، هنجمع بعد كده الاخر ونضرب في بوينت 3 ولا وات ايفر يعني. ف this is not a big issue now يعني. انما هو كويز انت المفروض انك انت تكون مستعد برضه لحل الكويز do your best يعني for this also. انما في other quizzes or chapter wise this also will be considered يعني. اوكي طيب يوسف
دكتور.
Yes.
It says that the quiz need to be graded.
طيب ماشي اوكي يعني
ما يطلع على طول؟
لا المفروض يطلع على طول طبعا، المفروض يطلع على طول.
بس عندي يقول need to be graded.
Maybe لانك انت you submitted late.
I submitted before the time.
طب ليه انت طلع لك جريدد؟ يعني الناس كلها ممكن يكون طلع لها
حتى انا دكتور.
لا عادي لو تدخل على نفس الجريدز، لو تضغط عليه بعدين تروح تضغط على نفس علامة التعجب ويطلع لك الجريد.
طيب على العموم ديت حاجه تكنيكال نو بروبلم فور ذس. يوسف اسحاق. يوسف مطلق.
I forgot to take my hand.
عباس فهيد.
Yes, doctor. When is the next quiz?
Next quiz احنا we finish load forecasting ف we have quiz on Monday. This quiz will be extensive quiz يعني على كل الشابتر. اوكي طيب.
طيب دكتور الميد تيرم تيست.
الميد تيرم لسه قدامنا شويه مع الاسبوع الثامن ولا التاسع يعني. برضه هيبقى حاجه زي كده لو هو اونلاين. لو رجعنا الفيس تو فيس مود هيبقى فيه يعني عادي يبقى از بيفور يعني. انما لو خلينا اونلاين برضه هيبقى على البلاك بورد يعني مع كاميرا مع بتاع ممكن نشوف نراقب الدنيا فيها ايه يعني زي ما الناس بتعمل في كل الكورسات الاخرى يعني. يبقى عندك كاميرا كده تحط لنا الكاميرا على الورقه اللي بتحل فيها والكمبيوتر ولا اللابتوب بتاعك ونقعد نشوف تحركاتك ونرصد حركاتك وسكناتك. اوكي.
طيب يا دكتور خلفيه اذا بنرجع ولا لا؟
ايه؟
اقول عندك خلفيه اذا بنرجع ولا لا؟
والله لا طبعا ده انت تسال فيها وزير الصحه فيها دكتور عبيدو يعني. ما نعرفش طبعا قرار لسه ما نعرفش عنه حاجه. فخليها ليتس كونتينيو وان شاء الله ربنا ييسر الامور ونرجع ان شاء الله.
دكتور بس استفسار بسيط، الكويز متى؟
الكويز اون ماندي ان شاء الله
الاسبوع الجاي
ان شاء الله. ان شاء الله.
يعطيك العافيه دكتور.
اوكي شكرا. طيب let us continue. We have still 5 minutes for the next topic in our course, which is the economic dispatch problem. Now we forecast the load. So what is the next question? If you still remember, what is the economic dispatch problem?
Choosing the generator to serve that demand.
Choosing the generators to serve that demand. هل هي دي economic dispatch ولا unit commitment? If we need to select the generators to cover the load, هل دي economic dispatch ولا unit commitment problem؟
هذه unit commitment هذا دكتور.
This is unit commitment problem. Selecting the generators to be committed to cover the load. This is the unit commitment problem. And this is the next problem. In my economic dispatch here, you are given a set of committed generators. يعني committed generators موجود. الجنريتورز اللي هي on معروفة بالنسبة لك given. So the question is how to distribute the load among the committed generators. In other words, how to distribute or what is the contribution of each generator in order to cover the total load. So this is the economic dispatch. This dispatch يعني توزيع. أنت بتوزع اللود among the generators. But this is the economic dispatch. So this is the operational planning problem here. After a short term load forecasting, we can do economic dispatch. Before the economic dispatch, we have to solve first unit commitment problem. But يعني we reverse لأن unit commitment is a sub problem of unit economic dispatch is a sub problem of unit commitment. So the agenda is in this part is to define what is the economic dispatch. We will also discuss the operating costs of the generators of the power plants. Generator cost curves. The input, what is the input, what is the output, and how much the cost. So this is the also very important curves that play an important role here for the economic dispatch problem. And we formulate the economic dispatch problem as an optimization. And in this case, we will give you a brief introduction about the optimization problems, unconstrained optimization, and there is no constraints, no limitations, nothing, and very, very simple problem, how to get like y equal to x square, what are the minimum value. So if there is no constraints, then you can say x equal to 0 gives you the minimum value of y. So this is the optimization unconstrained. And if we consider some constraints like power generated from each generator, it has a limits. And also if you have some equality constraint, summation of the generation must equal to the demand, and you cannot generate extra power without load. يعني it's a free commodity. Electricity يعني is a fresh commodity. You generate, you have to consume. So if you have some constraints, how to handle the optimization problem, and then we will see the economic dispatch solution if we neglect the losses in transmission lines, and if we also neglect the generator limits, and then if we consider the generator limits and we neglect only the losses, how to solve the economic dispatch problem as optimization. I think the time now is over, so let us stop here. We'll continue next class inshallah with the economic dispatch problem. Okay.
Doctor, about the quizzes, I think most of us got 0 in this quiz because of the time.
Because of the time.
Yes.
Yeah, I will take care of this before. بس أنا by the way يعني لو يعني معلش يعني لو اوكي لو بدأت تحسب بكالكوليشن وكالكوليتور والكلام ده it will take more time definitely. احنا بنقول linear regression وانت عندك 2 points, only 2 points. فانت based on these 2 points you can get the straight line equation. ما فيهاش اي calculation، ما فيها اي حاجه. يعني انت عندك 2 points، 1 was مثلا 75 و2 with مثلا 80. فادي 2 points. لو جبنا لك الثالثه الثيرد point then you need to calculate and then you need to use the calculator. Now with 2 points, if you think deeply before starting calculating, then you can easily do it. In 1 minute you can solve it.
1 minute the thought cannot come دكتور. يعني الفكرة في دقيقة واحدة ما يمديها تجي بسرعة.
لو انت قعدت 3 دقائق تفكر في المسألة وخدت دقيقة تحل.
لا دكتور، لأنه هو موجود، جبنا القانون وخلاص، اللي هو الواحد خلاص يكون على مود واحد على طول يدخل في المعادلة، لأن الوقت قليل. يعني لو شفت الوقت قليل يعني على طول بتدخل على الطريقة اللي معروفة، ما بتفكر في أي شيء.
طيب خلاص ماشي إن شاء الله. consider this. We will consider this. احنا by this we end the class. And if you have any question, stay with us. If you don't have